All right. In the last one, we finished up 3.7 and the inverses. There's more I could do graphically, but again, that would be something that is probably better suited to be in a classroom, unless I've got a graph grid and can move things around. I may come back to one thing in terms of that later on, but I usually don't test on it, so probably just going to push forward here. 0.3. This will be the last one, and then from this we'll have the last try me. 0.3 radicals. We're going to do just a brief introduction with this, and then we'll do more on Wednesday. We're going to be on 0.3 for the next bit. In this format, I don't know how it will go and how much I will be able to go through and do, or how in depth I'll be able to do. We'll do what we can, and we'll move forward as best we can. Okay, so we've dealt with a variety of functions up till now. We've dealt with linear functions. We've seen absolute values functions, rational functions, radicals, and we're going to get into radical functions. The idea, the thing that we need to recognize where it's a radical is when it's going to have this symbol. Okay? Anytime it has this, it's a radical expression. If it has an equal sign, then it's going to be a radical function or radical equation, and there's different processes for both. As we proceed, terminology will be key. So I will say phrases again and again and again, and we're going to want to be able to understand where I'm talking about with this. So I'm going to give you a basic radical expression, very generic, and assign terminology to it, and then I'll give you an example, and then from there you'll do your last try me. Okay? So with this, it's a basic radical. Anytime it has this, it's a radical expression. Our basic that I want to build on will be this. Okay, so this is a radical expression. The n here, the n, this is the index of the expression. It's also called the root. Okay, this value is always greater than or equal to 2. Okay. The m, this value, is the power, or the exponent. Now, in certain examples, you may see that moved outside the radical, and you see a set of parentheses around the radical. So you may see this, the nth root of a, and you may see it on the outside. Okay. Remember, as you evaluate, always evaluate within what we the way it's given. Don't say, well, it could be this. If I give you this, this is how I want you to approach it. Okay. The a, then, if this is the power or the exponent, the a in relation to where that power exponent is the base. So we have n is the index or root, the m is the power or the exponent, a is the base. The a to the m in this is called the radicand. The basic definition of that, the radicand is the entire expression under the radical symbol. Okay, the entire expression under the radical symbol. So in this case, it would just be the a. In this case, it's a to the m. This is the entire expression under the radical. Okay, so the radicand is the entire expression under the radical. So what I am going to do in this instance, I'm actually going to erase and I want to go through the example, and I'm going to want to label the index of the root. I want to label the power of the exponent, the base, and the radicand. This is you'll see this on the homework, and this is something that I usually test on. Okay, so let me erase here. Okay, so here is a basic. Let's do blue. So here's a radical expression. Okay, basic radical expression. Now, as we go through and we get more and more involved in the simplification of these, I will say phrases again and again based on the terminology I just gave you, and that's it. There's a reason behind it. Okay, so if I asked you for the power, remember it could be outside the radical, it could be inside the radical. So when I have this looks like the base, therefore that's the power. So the power is just 2. The base then would be the quantity m plus n. The index, if asked, hopefully you start saying, well, that was there, so that's 3. And then the radicand. The radicand is the entire expression under the radical symbol. Oftentimes what I have students do at this point, when I ask for the radicand, they will draw this symbol. The radicand is the expression underneath the radical symbol. So this is the entire expression, m plus n quantity squared. Sometimes the radicand and the base are the exact same when that's a 1. Okay, so what I'm going to do is I'm going to put another one over here, and this is going to be your try me. And it'll be in the next video clip for the solution. So here's your try me. Or, not try me, here's the you try. Okay, so here is your radical expression. So I want you to go through, and I want you to label the exponent. I want you to label the radicand. I want you to label the base. And I want you to label the root. Okay, now when I say label, what I would ask you to do is write out in the same manner we did. Sometimes as you draw arrows, I don't know if you're pointing to the base or to the radicand. So please write these out as you try them. And then you'll be able to check your you try problems after the submission deadline has passed. So these will be available to you at noon. Okay, so give that a try. This is the last lecture for today. We will pick up again on Wednesday morning, and we'll get into more of the radical stuff. Okay.